Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and this video is the third in a series of lecture videos on complex numbers. Let's continue. So last time we talked about division, multiplication, and absolute value. So we did a little bit of a quick introduction to absolute value, which is also called the modulus of a complex number. And it's defined as follows. If z equals a plus bi, and the absolute value of z is the square root of a squared plus b squared. So you basically use the Pythagorean theorem, because if you take a look at this picture, z is basically plotted as an ordered pair as a point, such as a comma b. And then the absolute value of z is defined as the distance from 0. Okay? And from the Pythagorean theorem, it just happens to be the square root of a squared plus b squared, which is always a non-negative number. And most of the time it's positive, because unless z is 0, it's positive. Great. So this is the definition for the absolute value. Let's see how we can apply this to a bunch of examples. All right, that's my channel, by the way. If you haven't subscribed yet, please do so. Now here's some examples. We're going to find the absolute value of these numbers. Let me go ahead and quickly write the formula down here. If z is a plus bi, then the absolute value of z is defined as the square root of a squared plus b squared, which is the distance from 0. Just like the absolute value of a real number, we define it as the distance from 0. Okay, how do you find it if z is equal to 3 plus 4i? So the absolute value is basically going to be the square root of 3 squared plus 4 squared. You're probably going to recognize this as the 3, 4, 5 triangle. And yes, the answer is 5. And this is the absolute value. Notice that we do not square the I, we just square the coefficients, or the real part and the imaginary part. Remember, we defined those before. Okay, let's go ahead and take a look at the second one. The a is 2, b is negative 7, right? Let's go ahead and write it down. Sometimes it helps if you just take notes. And then we're going to write this as a squared is 4, b squared is 49. If you add them up, you get square root of 53, which is positive. Great, let's go ahead and do this one. This one is interesting because there is no real part, which means a is 0 and b is negative 4. No worries, if a is 0, then its square is going to be 0, b squared is going to be 16, and the square root of 16 is going to be 4. Now this is significant because if you think about it, negative 4i doesn't have a real part, and we just take the coefficient of I, which is negative 4, or the imaginary part, and take the absolute value, and we get the answer. So whenever you have something times I, the absolute value of that thing is going to be the absolute value. Make sense? Hopefully it does. Here, it's the other way around. A is 5, and b is 0, but it's pretty much the same thing. 5 squared is 25, and b is 0, and this is going to be 5. Same scenario, we just take the absolute value when there's a single part, either real or imaginary. We always take the absolute value. Make sense? So when you see a problem like this, you don't have to worry about it. You can just find the absolute value. Take a look at the fifth problem or example, which is pretty interesting because this time we have variables, but no worries, the definition doesn't change. A is x plus 1, and b is the opposite of x minus 1, which I can square and get rid of the minus sign. So in this case, the absolute value is going to be the square root of x plus 1 squared plus the x minus 1 squared. So I can just write it as x minus 1 squared. When you square these two things, you're going to get x squared plus 2x plus 1 and x squared minus 2x plus 1. And then negative 2x and positive 2x cancels out. And we end up with the square root of 2x squared plus 2, which you can leave like that. You don't really have to take out a square root of 2 because 2 is not a perfect square, I mean. Okay, so we found the absolute value, and we kind of talked about the meaning of absolute value, or what it means. But let's go ahead and get into a little bit more detail, because this graph or this diagram doesn't give you everything. By the way, I think it's called the Argand diagram. Is that what it is? Last time I couldn't remember what it was called. Anyways, so let's go ahead and take a look at a couple facts here. If z, and we're going to repeat this a lot, so get used to it, z equals a plus bi is a complex number. If z equals a plus bi, theta is called the argument. What is theta? Well, theta is the angle that the absolute value, this segment, makes with the positive x-axis. So it's kind of like a positive angle in this case. So that's the theta. It's also called the argument, which is abbreviated as ARG. So when I write ARG of z, that means the argument or the angle. Of course, from basic trigonometry, you hopefully know that sine theta is opposite over hypotenuse. This is b and this is a. By the way, in the first quadrant, everything's positive, but in the second quadrant, you can't use the lengths. You have to use the coordinates. Okay? So these are the coordinates of our point, which is z, and sine is defined as b over r, and r is the absolute value. Remember that, by the way, which is the square root of a squared plus b squared. Tangent theta is equal to b over a, which allows you to find theta from inverse tangent. Why don't we just use sine and cosine? Well, you kind of have to use both, because you need to know which quadrant you're in. So the value of theta depends on the quadrant. For example, if sine is positive and cosine is negative, that means you are in the second quadrant, so your tangent is going to be negative. But there are two quadrants for which tangent is negative, so you have to look at sine and cosine. That's why you need to check the quadrant. Awesome. Now, if you look at these two values, sine and cosine, this is very important. And we do know that z can be written as a plus bi. If you replace a with this, and that comes from here, cross multiply, and cross multiply, and b with this, you end up with this. And then you take out the r by factoring, you get this form, which is called the polar form of a complex number. This is going to be important, and theta is in radians, and we're going to talk about this a lot. So z, our complex number, can also be written using trigonometry, and this is called the polar form. Awesome. I'm just going to leave it at that. So this is basically the end of the third video. Don't forget to subscribe, hit that notification bell, and stay tuned for upcoming videos. See you in the next episode. Bye.